Hi, it's Mrs. Moss here, and we're going to continue our discussion on energy by revisiting the electromagnetic spectrum and talking a little bit more about the Earth's surfaces and how it responds to energy coming in from the sun. So if you remember, the electromagnetic spectrum is the spectrum that shows all of the Earth's energy rays and wavelengths that come from the sun in a classified manner from increasing wavelength to decreasing wavelength. The electromagnetic spectrum is found on page 14 of your Earth Science reference table. And as I said before, it's all the wavelengths of energy in size order. And the way we measure wavelength is by looking at its crest or its trough. So we're going to measure the distance between this top of this wave to the top of this next wave. And that tells us whether we consider the wavelength to be longer or shorter, or if it's increasing or decreasing. This is a brief review of our last video. Now let's look at surface properties of our Earth and how the energy is taken in and absorbed by the Earth. So as I said in the last one, less than half of the solar radiation is received at the Earth's surface, which means that as the energy comes in from the sun, it can either be reflected, absorbed, refracted, and scattered. It could be transmitted through different mediums. So before it even hits the Earth, it can be changed or affected in different ways through our atmosphere and the gases in our atmosphere. Such as this diagram shows. It shows some of the wavelengths coming in and actually hitting the surface, but it also shows others that are getting reflected, and it also shows others that have been absorbed into the cloud and into the Earth and reflected back out. Now, so let's talk more about this reflection and this absorption and the radiation that's emitted from the sun. First of all, color of the Earth's surface will affect whether it is reflected or absorbed. Light colors will reflect the sun's energy, and dark colors will absorb the sun's energy, but it will also be able to re-radiate that energy as well. And if you remember what we mentioned about radiation, it's the emission or giving off of energy. So once the Earth absorbs the energy, it will also give heat energy off as well. So if something is a good absorber, it will also be a good radiator of energy. Texture is another surface feature that will affect whether energy is absorbed or reflected. Now, a rough, smooth, or textured surface will absorb and radiate energy, whereas a smooth or shiny surface will reflect energy. So these are terms that you need to memorize, and we're going to associate it with other substances that are within our Earth. For example, if we have snow, because it's light colored, and because when it falls and it falls in an even plane and it will fall flat, it can reflect and be a very good reflection of the Earth's energy coming in from the sun. Now, a pavement that is cement is rough and bumpy. It's also dark. So that will be a good absorber and radiator of the sun's energy. Here are a couple of pictures of substances that are being affected by the wavelengths and what's happening to it as it hits some of the surfaces. This is known as refraction. If you look at the pencil, when it hits the water, right at this point here, it almost looks like it's bending. That's known as refraction. Here is demonstration of light, sunlight coming in, visible light, and hitting a prism. This prism will scatter the wavelengths of energy that come in and make it go in all different directions. Again, here's the example that I mentioned before about the snow. Notice it's flat, notice it's white. So this is a great reflection of energy coming off of the snow and going back out. This is an example of transmission, just your everyday window. The glass acts as the medium in which the energy comes through. And here's another example of reflection. It's a pretty cool picture. We just wanted to put it in there for you. But you can see in this instance, the surfaces around this mirrored image is being reflected. This brings us to what we call the greenhouse effect. Now, some of you may know what a greenhouse is. And in this picture, you see that there is a house with plants. And this is known as a greenhouse. Now, there is a diagram on your notes that you're going to need to fill in as we go through and discuss what's happening in a greenhouse. Within a greenhouse, we have wavelengths coming from the sun that make up the electromagnetic spectrum. When it comes in, it goes in and gets absorbed by the plants and the other substances that are within that greenhouse. Well, they get absorbed and they then become, anything that's a good absorber is also a good radiator, so that will give off heat energy from those plants and those substances within that greenhouse. So it absorbs energy from the sun and then it starts to give off heat energy. Well, because of the way the greenhouses are designed, that heat energy is going to be trapped within the greenhouse. And it holds the energy, that heat energy, inside. So it's coming in as a shorter wavelength, mostly a visible light, and it's being re-radiated as heat or infrared radiation, and it is being trapped inside the greenhouse by the glass. Then when it does this, the wavelength, because it was absorbed by the plants and the other substances, it elongated and increased the wavelength. So it almost converts it or changes it into long wave radiation, which is known as infrared heat. Now, how does this affect the Earth? Well, it actually creates a similar design with the sun and the Earth and the clouds in our atmosphere. Incoming solar radiation reaches the Earth and is absorbed at the Earth's surface. Comes in as short wave radiation, just as we saw with our greenhouse diagram. Comes in as visible light, gets absorbed by the Earth's surface, and at that point it will also re-radiate infrared or heat energy. Now, as we said with the greenhouse, when it re-radiates it as long wave radiation. So you notice the difference in size of the wavelengths here from crest to crest when it comes in. After it's absorbed and gets re-radiated, we then have infrared radiation, which is a longer wavelength, and it goes out from the Earth's surface back into the atmosphere. Incoming is short, outgoing is long. But here's what happens. The greenhouse gases in our atmosphere, such as CO2, which is carbon dioxide, water vapor, and methane gas, they're in our atmosphere and they absorb the energy that the Earth is giving off. That infrared radiation, that heat energy, gets absorbed into our atmosphere and acts as the greenhouse glass did, and it will trap the heat energy into our atmosphere. So I'm going to go back to this picture. I need you to draw this picture in from your in your notes. If you need to pause the video and draw it perfectly, go for it. Please make sure you note the different wavelength sizes. You want this one to be shorter and you want this one to be longer, and it will be trapped by the clouds and the other gases that are in our atmosphere. So what is meant by global warming and why is it a problem? Well, global warming is a problem because too much carbon dioxide in the atmosphere would increase the amount of infrared heat and energy that's absorbed in our atmosphere. And the atmosphere may become unnaturally warm, which could result in the melting of the ice at the poles, and it would cause an increase in coastal sea level and flooding. So what this happens is, although we do have this naturally occurring absorption of heat energy, That is what helps us to live on Earth. It keeps it warm enough for our planet to be livable. However, too much greenhouse gases in the atmosphere will hold too much of that infrared energy, and it will then become too warm for us, and it will start to melt those ice caps, creating larger sea levels and flooding. Some contributing processes that increase the greenhouse gases getting into our atmosphere are industry, which burns wood and fossil fuels, and deforestation, because then the forests aren't producing oxygen to mix in with the energy that within the greenhouse gases in our atmosphere. So let's do a little review. In your notes, you're going to circle the correct answer. Which of the following best represents the type of energy received by the Earth and then remitted by the Earth? Go back and look at the diagrams that you drew and see if you can figure out which one. Well, it's diagram A. In this instance, it's coming in as shortwave radiation and it's leaving as longwave radiation. Coming in as UV or visible light, leaving as infrared. Which type of energy is represented by the radiation at B? Well, we have a choice. Is it visible light, insolation, ultraviolet, or infrared energy? It's infrared energy. You can tell because the wavelength is longer. And also, the Earth gives off heat. The Earth doesn't give off visible light. You don't see light coming out from the Earth's surface at night. It's not visible, so it's got to be in another form, which is heat. In this same picture, now we're asking which type of energy is represented by the radiation at A? Well, that's going to be visible light. It comes in as visible light and it leaves as infrared. And that's the end of energy, part 2. We'll continue with this at another video. Make sure you get all the notes down and we'll see you next time.